Good morning, 8th graders. So I'm going to go through a couple examples using the Pythagorean theorem, but when a side length is missing. So maybe you know the two legs and you're missing the hypotenuse. Maybe you know a leg and a hypotenuse, but you don't know the other leg. And so we're going to practice using the Pythagorean theorem to find these missing side lengths. So here I've typed up a couple of examples. The first one is, what is the length of the hypotenuse of a right triangle with leg lengths of 8 inches and 5 inches? And then there's nothing there. So the first thing I'm going to do is draw myself a visual of what this triangle might look like. Okay, and it says my leg lengths are 8 inches and 5 inches. So I'm going to label my two legs 5 and 8, knowing that this longest side across from my 90-degree angle is the hypotenuse, but that's the information that I'm missing. So that's the part I need to know. So this is my question mark, and in our theorem, that is side C. So if I write the Pythagorean theorem, a squared plus b squared equals c squared, and then I can fill in information. I know that A and B are my leg lengths, so I can plug in 5, substitute it in for side A, and then I can substitute 8 for my leg or side B, and that should equal c squared. So now I need to figure out what these numbers are. These are actually perfect squares where the side length is an integer. So I have the first 20 memorized, so that's really helpful for me right now. So I have 5 squared, which is 25, plus 8 squared, which is 64, equals c squared. And so I'm going to add these together. So 25 plus 64, so I have 9 and 8, so 89 equals c squared. But I don't want to know what c squared is. I want to know the length of the hypotenuse, which is c by itself. So I'm not finished solving yet. When we think about solving equations, we use inverse operations to isolate our variable, meaning if I am multiplying, I typically divide. If I am adding, I would typically subtract. We perform that inverse operation. So we're going to think about, how do I undo squaring a number? Well, that's something you've learned earlier in the unit, that's square root, or even back in unit 7, really, we talked about square roots. So the inverse of c squared, to undo that, I need to find the square root. And then whatever I do on one side, I have to do on the other side. So because these two sort of squaring it and then square rooting it, I could think of it almost like those cancel out those two operations. So I have c by itself, and then 89, that's not a perfect square. It falls in between two different integers. So I could leave it just as the length of my hypotenuse is the square root of 89. So that would be my answer for this question. For these questions, we're finding the missing length, but that's interesting because I have a picture, so that's really nice for me. So again, across from the 90-degree angle is my hypotenuse, so this is C. I could label this side A and B, and then I'm going to use my theorem again. A squared plus B squared equals C squared. So my a squared, 3 squared is 9. My b squared, which is 7 to the power of 2, that would give me 49. And this equals my c squared. So 9 plus 49. If you have a calculator, you could do it that way. But I arrive at 58. Remembering 58 is my c squared. And to find the missing length, I just want to know c by itself. So I have to perform that inverse or undo the squaring of my number. Again, those two operations cancel each other out. And so C equals the square root of 58. I'm going to jump down to this last one, okay? This one I think that you can do on your own now that we have an example. Again, remembering across from my right angle, that's my side C. So you could use 4 as a number for A and 8 as your number for B, and then you want to solve C by itself. What I like about this question is we're being asked, what is the length of the missing leg? So here, in all of our examples so far, those first two we did together, and this one you can do on your own, we were missing the hypotenuse. But what happens if we're missing a leg? So I want to write my theorem down again because I'm talking about a right triangle. So the Pythagorean theorem will be very helpful. And I'm missing a leg, so I don't know either A or B. And then we're told if you know the hypotenuse is 13, the hypotenuse, that's my C. So this is going to be 13 squared, and one of the legs is 12. Okay, so I can pick A or B, it doesn't really matter, to represent that 12. Okay, and then I'm missing A squared. So now I'm going to simplify everything that I can. So 12 squared, okay, that's 144. 13 squared, that's 169. So I have A squared plus 144 equals 169. And I'm going to solve this equation. I want to isolate the A by itself. So I would subtract 144. Again, whatever I do on one side, I need to do on the other. That becomes 0, so I don't need to add 0. I can just leave it as A squared. 9 minus 4 gives me 5, 2. So A squared equals 25. But I don't want to know A squared. I want to know the length of the leg. So the leg itself is that A. So if I know A squared is 25, again, I can work backwards or undo squaring that number to get A by itself. And I know the square root of 25 is 5. So this is a 5, 12, 13 triangle. One leg is 5, one is 12, and the hypotenuse is 13. So those are the different sides. So that's how I can work backwards if I know a length of the side of the leg, and I know the hypotenuse. I can still work my way back to finding the remaining leg.